So here we are with section 8.3. We're talking about solving systems by substitution. So this is going to be our third and final way of solving systems of two linear equations. So the substitution method, much like the name says, we are going to substitute one of the equations for one of the variables, then solve. So basically in this situation, one equation is already solved for. So we have a situation like this where y is by itself. What we can do, and we'll talk about this in a second here, is we can substitute whatever that is equal to in for that variable. So we're going to solve by substituting an equation in for a variable, or an expression, in for the variable. Then, as we did with elimination and graphing, we're going to write it as an ordered pair. Ordered pairs, x comma y. Remember, alphabetical order. So let's go look at a couple easy examples first, and then we'll kind of work our way up. So in a situation like this, you're actually already given one of those coordinates. So we know that x is 3. So we already know that the x coordinate is going to end up being 3. But we can use this information, just like you did with elimination. We can use this information to find out what the other variable is. So if I know that x is 3, anywhere there's an x, I can replace it with a 3. So I'm going to take this 3 and I'm going to put it right there. Now, it's going to work best if you use parentheses because that's going to keep your negatives in line. So here I have 2 times 3 minus 3y equals negative 12. Notice how I just took that equation that we have right here, and the only thing I changed about it was instead of an x, there's a 3. So now let's go ahead and solve this thing. So I got 2 times 3 is 6 minus 3y equals negative 12. And we can solve this as a two-step equation. We can solve this as a two-step equation here. Just subtract 6. And I've got negative 3y equals negative 18. You can solve for y by dividing by negative 3. And I got y equals 6. So now I know that y equals 6. We don't need to do any more work because we were given right away that x equals 3. What you can do is you can check your answers to make sure that this comes out right by using those numbers. And let's go ahead and pull up our calculator. So I know that I've got a 3 in place of x and a 6 for y. So I can say 2 times 3 minus 3 times 6. And when I hit enter here, 3 times 6, when I hit enter here, it should come up as negative 12, which it does. So this checks out. You're not always going to be given the x, and in some cases you might be given the y, as we have right here. Same story. We have a y. We know that in this place right here, we can tuck that negative 1 in. So let's go ahead and rewrite the equation. 4x plus 2 times negative 1 equals 6. Now it comes down to solving. So let's go ahead and subtract here. So I've got 4x minus 2 equals 6. So this turns into subtracting 2. We're going to add 2 to both sides. And we've got 4x equals 8. Now, at this point, what we can do is we can divide by 4, and I get x equals 2. X equals 2 and y equals negative 1. Now, I know that, so I can go ahead and put those in the ordered pair. Remember, x always comes first. So that's going to be my ordered pair. We can verify that this checks out by plugging it in the equation. So let's pull up our calculator. I know that I have 4 times x, which is 2. I go plus 2 times y, which is negative 1. And when I hit enter here, it should be 6. And it is. So we know that that checks out, and we know that this is going to end up being our solution. So 2, negative 1. So let's ramp it up a little bit and look at something like this. So the solution to the system where I have y equals 3x and x plus y equals negative 32. Notice how now it's not just a number. It's an expression. It's an actual 3x. It's no different than what we were doing before. We know that y is the same as 3x. We also know that y is the same as y. So what we can do is we can take this right here and we can tuck it in for y, because 3x, after all, as it states up here, is the same as y. So I can do this and I can say, all right, this is going to be x plus 3x equals negative 32. Well, look at what we just did. We took a y and we got rid of it. So now I have, I just replaced it. I substituted it, if you will. So now I have 4x equals negative 32. And what I can do with that is I can divide, and I get x equals negative 8. Now that I know that x is negative 8, I can take that information and I can plug it into one of these equations up here, top or bottom. Probably going to be easiest on top. Remember, make your life easy. So we've got 3 times negative 8 is going to be y equals negative 24, and x is going to end up being negative 8. We can just verify this real quick to make sure it's true. Plug it in the other equation there. So I've got negative 8 as x, so negative 8 plus negative 24, and it comes out as negative 32, so it checks out. Write it as an ordered pair, negative 8 comma negative 24, and you are done. Checked and verified. One more. You look at something like this, and we've got an expression. We got y equals 2x plus 7 and y equals x minus 1. It's going to be the same situation that you had before. We know that y equals 2x plus 7. We also know that y equals y. So there's no reason that we can't take this 2x plus 7 and plug it in place of that y. Because after all, y is equal to 2x plus 7. So I'm going to take this right here, and I'm going to tuck that in nice and snugly, and it's going to become 2x plus 7 equals x minus 1. Another way to think about it is, well, if y equals this and y equals that, these two things must be the same because they're both y. And that's what the equal sign is. Equal sign tells you something is something. So they're the same. So at this point now, what we're going to do is we're going to go ahead and solve. Let's get our x's on one side. So we'll subtract x over here. And we've got x plus 7 equals negative 1. Subtract your 7, and you find out that x now equals negative 8. As we did before, we want to go back to the original equations, and we want to plug in negative 8. So let's see. Let's go to the bottom one. It's going to make our life a little bit easier. So I have y equals, I've got a negative 8 minus 1. So y is going to end up being negative 9. And if I know my x is negative 8 and my y is negative 9, let's go ahead and plug these into the other equation just to make sure it's true. So let's plug in that one. It's going to be 2 times negative 8 plus 7. And when I hit this, we know that it's going to be negative 9. So hit enter. It comes out to negative 9. It checks out. So I know my ordered pair is going to end up being negative 8, negative 9. So that's substitution. One last thing to keep in mind, as we had before, infinitely many solutions and no solution situations. So remember, infinitely many solutions means that the lines are the same. Lines intersect everywhere. Everywhere. Those lines are the same. Okay? So what happens when you did this with elimination and it came down to 0 equals 0, it's going to end up being the same thing that you have here. It's just going to be using substitution. So we have x equals negative 2y plus 4. We know that we can take this and we can tuck that in for x. So it's going to be 3.5 times negative 2y plus 4 plus 7y equals 14. Notice how I took everything and copied it down the exact same except for my x, which my x is going to be the expression that you have up there. So let's go ahead and multiply this out and see what happens. So we're going to multiply this here. We got 3.5 times negative 2 is negative 7y. I've got 3.5 times 4 is going to be 14 plus 7y equals 14. So now when you're looking at this and you say, hey, I recognize that I have a negative 7y and a positive 7y. Those are going to cancel each other out, leaving me with just a 14 equals 14. Well, if 14 equals 14, of course it does. Does 14 always equal 14? Yes. Basically what happened there is everything canceled each other out and we're left with a true statement that's always going to be true. So this is going to be infinitely many solutions. because when we went back and we checked our work, we said, okay, we did everything correct. We plugged in, we multiplied out, we came down there, we got something, they intersect everywhere. They are the same line. And if we wanted to manipulate these equations, we could make them manipulate them to be the exact same equation if we wanted to. No solutions is going to be when lines never cross, as we talked about with graphing. No solution, they are parallel lines. So you look at a situation like this, and we're going to do elimination one more time. We know that y equals 3x minus 11, so I can take this 3x minus 11, and I can plug it in for y. So I got 3x minus 11 minus 3y. We don't need those parentheses, but I just want to show you that I'm writing the equation the exact same. So I got 3x minus 11 minus 3x equals negative 13. We don't need those parentheses. What we do see, however, is that we've got a negative 3x and a positive 3x that are going to cancel each other out, leaving us with negative 11 equals negative 13, which that is not true. That will never be true. This makes no sense, so this must have no solution. If it's no solution, remember those lines are parallel. They have different y-intercepts, so they will never, ever cross.